The range, interquartile range, and 5-number summary are good ways of getting a sense for our data. But if we're going to truly measure variability, we will need a mathematical way of doing it. And to do it, we're going to need to solve our problem of the average deviation scores equaling 0. To make this easier, we need a data set. So we survey 6 statistics students and ask them to tell us how many dog toys do each of their pets own? And here are the answers. 8,71374. To calculate the mean, we add them up and divide by n. The sum of x is 30. Divided by 6 equals 5. So the mean is 5. But what about the variability? We could just take the measurement error between the mean and each x-score and average them. And this would be called the mean average deviation. But it doesn't work, because the average deviation always equals 0. The mean average deviation always equals 0, because the deviations below cancel out deviations above. Some are positive, others are negative. Angry Stats Bear says, "Don't use the mean average deviation. It makes me mad." So what can we do instead? We need a way to make all of the negative deviations positive. I suppose we could use the absolute value and just declare that all of the negatives are now positive. But just like all magical thinking and delusions, simply declaring that things are now the way we want them to be and then pretending is a recipe for disaster, especially when it comes to algebra. So we need something better than name it and claim it statistics. We need a better way of taking the negative deviations and actually making them positive. Enter the sum of squares. We can take advantage of the fact that when a number is squared, it is always positive. We will square the deviation scores. Remember, they're also called errors. And then we will add up the squared deviations or errors to get the sum of squared errors, or the sum of squares, 2 names for the same thing. Putting this into a table, we return to our data about dog toys. We will put the numbers in the first column, then create a second column with the mean. For each row, x minus the mean gives you the deviation score. Now, square each deviation to get squared deviation or squared errors, and then add them up. Congratulations! You now have the sum of squares. This is a great start. But remember, we're looking for an average amount of variability. So the next step will be to divide by n and create an average.